So the basic agenda is I'll go over what is why is now particularly a good time for OCP consideration, and I'll discuss next kind of a brief introduction to who is Wiwynn, and I'll dive into some evolution of the OCP products that Wiwynn has been involved in since the inception of OCP. And I have also a successful OCP case study we had this previous year that we can share the details with you, so you can get an idea of how previous customers have actually migrated to OCP. And as well as I will have a Wiwynn Intel RSD demo for you guys. And at the end, I'll also inform you how you can actually test perhaps your software on Wiwynn OCP hardware. So yeah, we can communicate and then see how you can actually get that going right away, so you have a better idea of what OCP is. Okay.
Next slide.
Yeah, next slide. Let's do next slide, please. Okay, so the first thing is, why is now a good time for OCP, right? So if you look on the chart, we can see we are in the intersection between Broadwell and the next generation Xeon processor, Skylake. So this is a good time as the microarchitecture is going through the change. So the hardware you'll be getting is the latest, not only in OCP as well, but also with the microarchitecture. So so from this slide, it's basically just a good timing to consider your OCP solutions that we think. Okay, please next. Okay, so on this slide, basically is to give you an introduction of how Wiwynn has evolved with OCP from the very beginning. Just as you can see, we began in the year 2012, and that was around the time that OCP really begun and spun out of as a small, almost like a hobbyist project. And along the way, we've been closely following and getting certified, such as achieving the OCP Certified Solution Provider, and all the way up to we are now a platinum member in the OCP Foundation. And as well, if you go to the OCP website and you click on the OCP Marketplace and you select OCP Accepted, you'll see we have 12 out of 17 products available there. So it's a considerable majority. So in essence, yeah, Wiwynn has been committed and been following closely the evolution of OCP from the beginning. So we're happy to share and discuss with our customers any adoption of this technology. Okay, please next. So, and a question that you may be wondering is perhaps why, out of all the involved members in OCP, or why Wiwynn, right? So one factor that we have is we have a global manufacturing reach, which means faster time to market. And in particular interest for you guys would be in, we have a manufacturing resources available in the Czech Republic. So that can provide local time to market very, very fast, and as well as a global footprint. So we are committed to globally push out the OCP technology. Okay, please next. And as well, you can see on our website, we have various global partners, and in particular interest for you guys would be our European partnerships. So in our region for Europe, for example, you can see Circle B listed for our EMEA partner. And if you go to the link at the bottom, you'll be able to see a full list of all our other partners. Okay, please next. Okay, so now we get to our product line, so the OCP products evolution. And what Wiwynn offers is pretty much the full range of data center infrastructure for OCP. We have the main compute models, various storage models, and also as well as providing the rack and all the inner components for customer customization. Okay, please next. So beginning with the evolution of OCP servers. Yeah, as we can see currently, even right now, OCP is an always open and evolving technology. So exciting new architectures are in development already. But going back a little, just to get a little view of the history is, so on the left, we have the SV7220, and that uses kind of the older microarchitecture, and that comes up to the currently available SV7220G2 that we have. It comes in 3 SKUs. And the thing about OCP versus maybe your idea of traditional 19-inch is there's various mechanical differences. For example, OCP is very front axis, whereas a previous 19-inch would be more rear. And then the thermal probably is more enclosed for the traditional, but OCP it has more open because the design consideration is just easier pull out or plug in and easier manageability from a physical perspective. And there's also various customization of boot options available if you're transitioning from the OCP to perhaps a 19-inch SKU world. So, but the opportunities is you really get in terms of the front axis and manageability. You can get that from the OCP design, and as well as the power design is currently in ORV2 rack. It shares the single bus bar. So what they've done is removed any perhaps extraneous parts outside of the compute module itself. So you can just simply plug it in and it attaches to power stream from the rack, the rack bus bar. So, and yeah, there's current developments now, and so that's kind of been an overview of how it's evolved from the Open Rack V1 with 3 bus bars, and then now to 1 bus bar, and we'll see how that evolves in the future. Okay, please next. So this page is basically evolution of the OCP storage we have. And the one you see on the left is essentially the SAS 6G and 12G technologies. And then the one in the middle, the SV7110, is a storage server technology. And we come to kind of our most recent, as well as in industry that's really popular, is the NVMe JBOF. So with a lot of SSD usage, especially our high performance storage needs. So, and as well, there's new OCP technologies coming down the line to further take advantage of these faster storage speeds. So, okay, please next.
Oh, sorry.
Oh yeah, that's okay. Okay, so now we come to a successful, that's okay, OCP case study that we've had in the past. And what this is about is basically Wiwynn and Itochu Techno Solutions America. We partnered to help a leading web company in Japan to perform its first OCP migration. And so you'll be able to see how this customer has migrated to OCP, perhaps with some of the same concerns you guys might have right now, and I'll discuss later. And then the information from the next few slides is from Hisatomo Tanaka, who's the director of international sales at Itochu, and we have a presentation on the OCP Summit 2017 on YouTube that you can check out as well. Okay, please next. So the first thing is about OCP from this customer view is that it's simple for the user, right? Like I mentioned, the front axis and even the toolless maintenance. As you can see, what they do is they indicate all the green things are where you can easily use toolless maintenance. And also it's stable because the compute nodes are stuck in a 3-node cubby, and that cubby plugs right into the single bus bar in the back of the ORB2. So this provides a stable infrastructure for basically the usage of OCP. Okay, please next. So what this customer has also noticed during this migration is that the ecosystem is mature of OCP. And so instead of, one consideration is that instead of discussing with OEM and black boxes, going through the extra layer, the customer wanted more visibility and transparency about pricing so they could be more competitive, and go down to each component level and determine the pricing. So what Itochu and the customer did was they actually build a supply chain together and with the customer to assure the quality manner of how to determine all the pricing so you can get more savings. And then also in terms of the operation, at data centers, you typically have two kinds of boxes for spares. So these boxes might have different policies, troubleshooting, or serviceability, which could be a little more complex situation than we like. So instead of having those two different boxes, the OCP allows a single spec and SKU to standardize the part levels. So this brought about easier ops, and transparency with the manufacturers. And because the stock is standardized OCP parts, so you have a less necessity for spares. And all in all, they felt this really brought it up down to efficiency in operations. Okay, please next. And OCP, because it's proven at a hyperscale, the hyperscale people have been using it, for a long time, and they are committed to the latest, right? So it's very innovative. So, and as well as you can see all the yearly, annual new announcements at the Open Compute Summit, as well as OCP Tech Day like today, that you can see that OCP technology is very innovative and reliable already. Okay, please next. Okay. So now that we've seen kind of heard the nice things about OCP for a customer's migration, what are some of the challenges they had to consider in terms of migrating? So the first thing would be a software perspective. Your applications need to be able to scale out. So that's one kind of the requirement. So in terms of like the web server, the distributed databases, Hadoop, object storage, you need to have the ability to scale out from your software built in. And it's better to have your own data center, but it's not required, because having your own data center offers more flexibility, and you would need OpenRack. And OpenRack is the same external dimension as the 19-inch rack, but yeah, to really to take advantage of the OCP technologies, this could be a consideration. And finally, the one thing to consider about the pricing would be a bigger volume would be more beneficial. So what they've thought of, the customer had thought is buying perhaps buying OCP parts together with other customers, and then by standardizing the SKU with other people to get possibly more savings. So the cost of the rack and PowerShelf and establishing like a new QA process would be relatively high. But buying if you buy a smaller part, so this would be. I mean, these are some of the possibilities that are going on. So all in all, yeah, this would be the some things to consider around OCP adoption. Okay, please next. Okay, so the next thing I will discuss. I just want to mention at this point that we do have a rack available at the Facebook Disaggregate Lab. It will have these kind of the components you see on this chart that you can test your software on. So please feel free to contact us if you really just want to dive in OCP right now and have it available to try out your software. So with that, let me try to now show you a live demo we've prepared when we went into RSD. So, well, actually, Menno, would you please play the video for the audience?
Yeah.
Okay, great, thank you.
Wiwynn. In the community of Open Compute project, all the members are looking forward to embracing prosperity from sharing and synergy. For years, Wiwynn has been carrying out commitment as an OCP contributor, delivering best quality solutions and latest infrastructure technology in the spirit of Open Compute. Wiwynn achieves the highest level of IT workload optimization for today's data center.
All right, Menno?
The matter of development of cloud computing allows server virtualization on a physical node and resources, such as CPU, storage, and memory. This could fall short for some applications, while others are excessive in utilization. Some applications are more computation power hungry, while the others are in need of storage capacity. Hence, the demand to flexibly compose a node with extensible resources has grown to address the resource optimization. As a leading hardware provider and OCP solution provider, Wiwynn has been working closely with Intel to unlock infrastructure potential. Intel rack-scale design is a logical architecture that enables scalable pooled resources and maximizes utilization. Simply put, Intel RSD unlocks resources from physical servers, creates virtual pools of resources, adds physical resources into pools if pools run out, applies resources to application workloads, composes resources, and reconfigures as requirements change. The pooling technology can extend to applications on other PCIe devices in the future. Wiwynn offers a series of products for OCP and 19-inch racks for Intel rack-scale design integrated with Intel Xeon processors. Enjoy the best workload optimization and TCO for your data center. Wiwynn.
Hey. Hi, Menno, do you have the...
Yeah. You're on.
Okay, you can see my screen, right?
Yeah.
Okay, great. So, all right, to begin, that video was just a brief introduction of what essentially the concept of Wiwynn Intel RSD is. So let me, what I have here is is actually now 4 windows. So you guys see all the 4 windows that I have up?
Yes.
Okay, great. So the first window is the upper right one, and what you want to do, well, the first thing I always want to mention is the RSD interfaces just really need 1 window, but the reason I have 4 up is to give you a better idea of how the story or how RSD works. So the first thing in this window you see is you have your compute pool, your NVMe pool, and your storage pool. And to just briefly explain what the RSD technology does is, in the previous history and technologies, we've really been focused on the virtual machine and kind of its evolution. But what now Intel RSD does is go down to the lower level and it disaggregates on the hardware level, right? So, and it creates pools into a logical compose node, basically your physical disaggregated sources, and turns those into a composed node. So that offers scalability as well as full utilization of your resources. So knowing that, that's why we have essentially, the pools of all their physical resources. So this is running on real OCP hardware right now in Wiwynn's lab. So we have 3 blades here, 15 NVMe drives, and a storage pool offering this amount of terabytes. Now the first, to understand RSD, the first action you would do would be compose a node, right, out of your physical resources. So let me just type, for example, my node 1, and we have a node 1 description here. Give it a description. in this section, you can specify, like a search filter, what are the minimum requirements that you want to search for. So let's search for Xeon E5 processors and search like a minimum of at least 14 cores. And you can also specify what kind of local drives that you may want in case you want a boot drive, but for demonstration, we'll just leave that. And so for remote drive, IQN, let's give it a 3 terabytes. And you can also, yes, specify any VLAN that you want this logical compose node to be part of. So, okay, we'll try that. So, okay, so what we see now is in textual format, we created the compose node. And if you see on the right-hand side, it says 1 blade has been allocated. And indeed, 3 terabytes has been decremented from the storage pool. Okay, great. So now let's check out the NVMe thing for this. So we click Attach NVMe here. And we click Add. Let's give this compose node some more power by adding an NVMe. And while this is going on, just do want to mention that this GUI of our Wiwynn Intel RSD is based on the Wiwynn Cluster Manager, which is a full data center management suite. So what you see here is really the interface to RSD, but if you use the Wiwynn Cluster Manager, it has many more features such as notifications and perhaps deployment and various other tools or asset management that you would use in your typical data center responsibilities. So as we can see here in my mouse cursor on the left window, we have an NVMe drive attached in text. And if you look graphically on the right-hand side, one NVMe drive has been attached. So what we can also do is come down here to the console. And if you see, previously we did not have any NVMe drive, but now we do indeed have an NVMe drive attached. So that just further reinforces to show you that this happens on the actual machine. And if you look on the left-hand side, we also have a handy interface, so you can see exactly which NVMe drive is attached to which compute node. So you can, from there you can see how the connections are actually working from a graphical view. Okay, great. So now that we have that, let's try to, let's try to give it a, let's try to give it a second one. Just to show you that you can have multiple NVMe drives. And, okay, so while this is going on. And as well as, we also have a feature of, as well as once you create your logical compose node, at this time, RSD technology also enables you to deploy any operating systems that you might want to select, which we might expect from this kind of technology. Okay, great. So you see textually that we've indeed added a second NVMe drive, and it also shows graphically. And we should be able to see it here. Okay, great. We see 2 of them down here in the console. Now, with that said, let's try to remove it so we can see how the pool technology actually works. Okay. So what we should see is that textually you should just have one NVMe drive, and in the pool it should be returned the one that we just removed. And okay. So while it's going on, like in terms of VLAN, you can set VLAN for your various logical compose nodes. So in that way, it's easy in terms of the network for RSD technology to separate by the VLAN layer. your logical composed nodes. So we see now that in textual format, the NVMe has been removed and it has been placed back into the NVMe pool. And if you want to deploy any operating systems on, like, let's say your logical composed node, we have this interface, so you can just select minimal Ubuntu, and you type in your login, and yeah, once you click OK, it'll start deploying. Just show the middle one for demo purposes, and it will start deploying on your logical composed node. And through that, once you got that, you can put on the higher level software layers on top of that. So yeah, essentially that pretty much sums up kind of the RSD demo. And just the final message is pretty much that Wiwynn and our partners were really committed to OCP, and as well as even not just hardware, but as you can see, Wiwynn into RSD, the software side, we are heavily and also deeply partnered to bring this technology to the next step in the software-defined data center. So I hope you guys enjoyed and learned something from all this. And yeah, I guess that pretty much concludes my part of the presentation. And if you guys have any questions at this time, I'd be happy to discuss with you. All right, thank you.
Thanks, Ethan. Any questions to Ethan?
Is this software something that you set up once?
Ethan, is this the software that you just need to set up once for the system?
Yes, RSD software, you just, okay, let me just briefly explain the architecture is, yeah, the answer is pretty much you just need to set up once. And through this interface, you can build logical composed nodes, or you can remove the nodes through this interface. So you don't need to restart this software every time. And this won't affect yeah, you don't need to reset any time in terms of application changes. You will not need to reset the RSD software.
Thanks. Any other questions regarding this OCP servers?
Oh, yes?
Okay. So, if no, any question? No. Thanks, Ethan. We don't have any questions. Thanks for the presentation, and we will give you contact.